This is a walkthrough of problem 4 on exam 1 in module 2, which is on page 49 of the book Problem Solving Guide for Electromagnetism and Optics. Problem 4 is the muon is an elementary particle that has all the same characteristics as an electron, except that it is 207 times heavier. It has the same charge, the electronic charge, 1.6 times 10 to the minus 19th coulombs. It's negative. It has a mass of 1.89 times 10 to the minus 28th kilograms. A muon's traveling at 10 to the 6 meters per second, just above this plate. The plate is 1 meter by 1 meter, a square. The muon is deflected and upward a distance of 2 centimeters over the 1 meter distance across the plate. That's 1 meter. The deflection from the straight line is 2 centimeters. Part A. The muon is unstable with an average lifetime of 2.2 microseconds. How long does it take the muon to go the length of the plate? Part B, what is the net charge on the plate? There's a good diagram, came with the problem. Let's put the distances on there just to mark them out. So that's the 2 centimeter deflection, and that's 1 meter plate. Now remember, it's a square. It looks like a cross-section of a circular plate, but it's a square plate. This is a projectile motion problem. Acceleration is only vertical. The initial speed is only horizontal, somewhat similar to gravity. X is vt, there is no acceleration in that direction. The muon's speed in the x direction is constant, and it's 1 million meters per second. So if you're going 1 million meters per second, and you go 1 meter, the time it takes is 1/millionth of a second. A microsecond, 10 to the minus 6 seconds is 1 microsecond. It takes 1 microsecond for the muon to go across the plate. That's part A, the easy part. Part B, what is the net charge on the plate? How do we get that? The muon is pushed upward by the field. The field is produced by the charge on the plate. The muon's negative. The charge on the plate must be negative. There's 2 ways to determine the field above a charged plate. One is treating the plate as an infinite number of point charges and integrating the field from each point charge. The other way is to exploit the symmetry of the geometry and use Gauss's law. Let's use Gauss's law. So now we're going to focus only on the plate. There's the cross section. We want to get a good Gaussian surface. And that surface is a box that fits snugly around the plate. The muon stays close to the plate. So there's our box. It's 1 meter by 1 meter by, 2 centimeters high, 3 centimeters high, 4 centimeters high, something small. We don't want stuff leaking out the side. We want it all to go here. And remember, these are 1 meter by 1 meter, so that's a big area. The field lines are going to the top square surface and the bottom square surface. The field lines are coming in at right angles. And since the Gaussian surface has the entire plate, Q enclosed by the Gaussian surface is the charge on the plate. There's Gauss's law. The area through which the field lines are penetrating are the top and the bottom, so that's 2 square meters. The field is the same at the top and the bottom. I can just use 1e to represent the field at those 2 surfaces. And I have 2 unknowns. I have 2 unknowns, only 1 equation. What the heck? How do we solve this? I got to think. The field puts a force on the muon and pushes it 2 centimeters upward in a time of 1 second. The initial speed in the y direction is 0. We can get the vertical acceleration. From the acceleration, we can get the force, F equals ma. From the force, we can get the field, F is QE. Sounds like a good plan. I like it. Let's see what happens. In the vertical direction, Y is 1/2 at squared plus VIYT. VIY is 0. Muon's moving horizontally initially. I have the distance, 0.2 meters, which is 2 centimeters. There's the time. I can solve for a sub y. A sub y is going to be big. 4 times 10 to the 10th meters per second squared. 40 billion meters per second squared. That's a lot of g's. From the acceleration, we can get the force because we know the mass. It's given. F equals ma. There's the mass of the muon, the acceleration of the muon. This is in the y direction. The force in the y direction, 7.56 times 10 to the minus 18th newtons. From the force, we can get the field. F is QE. We know the charge. It's the same as the charge on the electron. We know the force. We just calculated it. Now we can get the field. 47.25 newtons per coulomb. Now, if you remember, we got stuck on Gauss's law because we had two unknowns, but now we have the field. So now we can stick it in and solve for Q enclosed. E dot A, 4 pi K Q enclosed. Q enclosed is 0.84 nanocoulombs, but this is just the magnitude of the charge. Muon has a negative charge, the plate's repelling it. Like charges repel, so the plate must have a negative charge. So we simply say the net charge in the plate is minus 0.84 nanocoulombs. That's problem 4 from exam 1 in module 2.